this chapter, we have learned how to solve a system of equations in two ways. The first way was by graphing, where you take two lines, you graph them, and you see where they intersect. The next way we did was with substitution. Substitution is one way of getting rid of a variable when you have two equations. Elimination is another way to do that. So in substitution, we're first going to do this problem with substitution. In substitution, the first step is to get one of your variables alone. It looks like this y might be the easiest to get alone because it's positive and there's no coefficient. A coefficient is just a number in front of the variable. So if I subtract 3x from both sides, I get this y alone. Now in substitution, I would take this and plug this into the other equation for the variable that I have solved for and get 2x minus the quantity, negative 3x plus 10 equals 5. All this equation is the top equation with the bottom equation plugged in for the solved variable for the y. So now, in order to solve this equation, I just need to distribute this negative. So I'm going to get, we get 2x plus 3x minus 10 equals 5. If I combine like terms, I get 5x minus 10 equals 5. Add 10 to both sides, and I get 5x equals 15, which means that x equals 3. Now that I know that x is 3, I can plug that in to this equation to get the y variable. So negative 3 times 3 plus 10 equals 1. So the point of intersection is 3, 1. Hopefully that's a little refresher for you about solving with substitution. Now let's do the same problem, but using the elimination method. The elimination method is often much quicker. When you're using the elimination method, the idea is to look at the two equations and see if you added the two equations together, would one of the variables cancel? Here, conveniently enough, it does. If I add 2x plus 3x, I get 5x. That's not the one that cancels. Negative y plus y is 0. Therefore, the y variable cancels out. If the y variable cancels out, now I have a nice equation only in one variable that I'm able to solve easily for x. Dividing by 5, and I get that x is 3. Which, if you remember, is what I got when I did it the other way. Now I need to take this x equals 3 and plug it into either equation to figure out what the y should be. Doesn't matter which equation you use, so let's use the top equation. So if I put that x equals 3, plug that into the top equation, I get that. So I get 6 minus y equals 5. Well, 6 minus 1 is 5. So both ways I do the problem, I get the same answer. Now let's just go through the steps for solving a system with elimination. The first step is to multiply a number so that adding will make one of the variables cancel if necessary. In the first example that we did, step 1 was not necessary. When we added the equations together, one of the variables canceled already. But sometimes it won't, and you have to multiply the equation by something in order to get that to happen. We'll talk about what that means in the next example. Then you add the two equations together. When you add those two equations together, the goal of that is so that your new equation will only have one variable in it, so that you're able to solve for that variable. Then you solve for the remaining variable. So you got one of the answers, now you have to go back and find the other one. So you're going to plug that answer that you got in step 3 into one of the equations, it doesn't matter which one, and solve for the missing variable. And then you just have to remember to write your answer as a point. Hopefully you realize that that is the point of intersection between the two lines. Now let's try an example here. So let's look at step 1. Step 1 says multiply one of the equations by a number so that one of those variables will eliminate when you add the equations. So if you look at this example here, you should ask yourself the question, if I added these equations together, would something cancel? And the answer here is yes. The x variable will cancel if you add these equations together because the coefficients are opposite. Negative x plus x is 0. 2y plus 8y is or 6y is 8y. 12 plus 20 is 32. Now I can easily just divide by 8 and get that y equals 4. So that part of the elimination method is a lot easier than substitution for this particular example. Now that I know that I have one of my variables solved for, I know that the y is 4, I still need to go back and find the x. It doesn't matter which equation you use, I'm going to use the bottom one here. X plus 6, I'm going to plug in what I found up here. So now I know that x plus 24 is 20. If I subtract 24 from both sides, I know that x is negative 4. So now I know that negative 4 is the point where these two lines intersect. I don't need to graph them. Whatever the graph looks like is not really that important. You know the point of intersection at this point. Now let's look at this example. The first thing you should always ask yourself is, if I add these equations together, will something cancel? And here, yes, something will cancel if you add these equations together, so you do not need to do step 1. So let's just add these two equations together. 5x plus negative 5x is 0. Negative 8y plus 8y is also 0. 10 plus 3 is 13. So without doing much work at all, I've concluded by this, I got the equation that 0 equals 13. This is obviously not a true statement. If this comes out to be something that's not true, that means that there's no solution to this system. If there's no solution to this system, the lines therefore must be parallel because they don't intersect anywhere. There's no intersection point. Now let's look at these two equations. So here, the first thing that you always have to ask yourself is, if I add these two equations together, will something cancel? And here the answer is no. Nothing will cancel right away. So here you do have to complete step 1. Step 1 says that you have to multiply one of the equations by a number in order to get something to cancel. Which variable you get to cancel is up to you. I always look for the easiest one. So the x's wouldn't be that easy to cancel because you may need to do a little bit more work for that. But the y's will cancel fairly easily if I multiply the bottom equation by a number that makes these two cancel. That number is 3. The reason I wanted to pick 3 was so that now the coefficient of the y is negative 3y, which when added to this y would make that cancel out. So I'm going to take this bottom equation and multiply by 3. I get 15x minus 3y equals 33. I'm just going to rewrite the top equation here to keep myself organized. So now that I have step 1 met, I've multiplied by something to make one of the variables cancel. I'm going to go ahead and add these two equations together. 2x plus 15x is 17x. 3y minus 3y is 0. That was the goal. You wanted the y's to cancel. Now we have to add 18 and 33, and we get 51. The next step is to just solve this for x, which is going to make me divide by 17, and I get that x is 3. Now I'm still not finished because I have to go back and figure out what the y is. Doesn't matter which equation you use, I'm going to use the top one. So here I have 2 times x, which I solved to be 3, plus 3y equals 18. So now I have 6 plus 3y equals 18. Solving this simple equation for y is going to lead me to get that y equals 4. So now that point is the point of intersection between the two graphs. So I just want to talk quickly about how to check your answer. So we've done this in the previous lesson, but I just want to refresh your memory about it a little bit. So in order to check an answer to a system, there's an easy way to do it. All you have to do is plug that point into the original equations, into both of them. So if I take my original equation, 2x plus 3y equals 18, and plug in this point. Let's see if I get something that's true. So 2 times 3 plus 4 times, plus 3 times 4 should equal 18. All I do is I just plug these values for this point into this top equation. So I get 6 plus 12 equals 18, and that's true. I still have to do it with the second equation as well. So if I take the second equation and plug in my point, I get that 5 times 3 minus 4 should equal 11. And that is true. 15 minus 4 is 11. That's how I know that my answer is right. So in any test or quiz, you should be able to tell whether or not your answer is right. And if you get something that's not true here, let's say you get 20 equals 11, that means that somewhere in your process you made an algebra error. So go back and look and see if maybe you added something wrong or you missed a negative, and hopefully you'll be able to figure out what the right answer should be. Thank you for listening. Please answer the questions.